Assalamualaikum everyone. So now we will continue with the third applications in geometrical application, which is the intersection of a point and a plane. Alright, so let's look at example. Given a line L is x equals to 1 minus t, y equals to 3t, and z equals to 1 plus t, and a plane S is 2x minus y plus 3z equals to 6. And then find the point where the line L intersects with the plane S. Okay, so remember, if you have the word intersection, okay, intersection means you want to find a point where two things are intersects with each other. All right, so in this case we want to find the intersection point between a line and a plane, right? So we have here a line and a plane. And another one, if we want to find the intersection point, basically we will use simultaneous equations. For example, in this case we have the similar terms we have here is x, y, z in L, and we also have x, y, z in S. Okay, by applying the simultaneous equation, now we will substitute the equation from the line L into the equation for the plane S. Okay, so now we will say that substitute L into S. Okay, so we have here, when you substitute your x is 1 minus t, that means you will get 2 times 1 minus t. Okay, and then minus your y is 3t, and then plus with 3z, and your z here is 1 plus t equals to 6. Alright, so now when you simplify, we will get 2 minus 2t minus 3t plus 3 plus 3t equals to 6. Then we will get negative 2, negative 3 and plus 3. So negative 5 plus 3 is negative 2t. Okay, and then we will have 2 plus 3 is 5. So you will get 6 minus with 5. And now you will get your t will be negative 1 over 2. Okay, remember here your aim is we want to find the intersection point. Okay, we want to find the point here. That means if you want to find the point, your answer must be in the form of x, y, z. A point with x, y, z. Right? So what we will do now is you will substitute the value of t that you will get here into your x, y and z. Where is the x, y and z? This one. This is your x, y and z. Okay, so next step is substitute t equals to negative 1 over 2 into L. Why? Because we want to find the point in the form of x, y and z. Okay, so your x will be 1 minus with a negative 1 over 2. Then you will get it will be 3 over 2. Your y will be 3 times negative 1 over 2. You will get it is negative 3 over 2. And your z will be 1 plus negative 1 over 2, which is equals to 1 over 2. So now you will get your intersection point equals to 3 over 2, negative 3 over 2 and 1 over 2. So this is your intersection point between the line L and the plane S. Okay. Okay, let's continue with the last application in geometrical applications. Okay, we have here the intersection point between two lines. Okay, so let's say given two lines in space, we have L1 x equals to 2t minus 3, y equals to 4t minus 10, z equals to negative t plus 3, and L2 is x equals to 2s minus 1, y equals to negative 3s plus 1, and z equals to 5s minus 4. Okay, now we want to find the point of intersection of lines L1 and L2. Okay, so firstly, again, we have to find the intersection point, meaning here we will use the simultaneous equations. Okay, so let's see here, the simultaneous equations that we can write here is for x, y, and z. So look at here, we have x, the similar terms we have here, x, y, and z. Okay, all right, so for the first one, we will have the simultaneous equation for x, that is, we have 2t minus 3 equals to 2s minus 1. So if you can see here, there are two different parameters involved in this equation of line. That is, the parameters is 40, and another one, the parameter we have is s. Okay, so that means here we want to find the value of t and s. Okay, so we consider this one as the first equation. All right, continue with y. So y we have here is 40 minus 10 equals to negative 3s plus 1, and another one we have, so this one is second equation, and another one we have is negative t plus 3 equals to 5s minus 4. So this is the third equation. Okay, so from the third equation, okay, we will write, okay, we can write your t as the subject. That is, if you write t as the subject, okay, you will have it is equals to 3 minus 5s plus 4. So your t is 7 minus 5s. So let's say we consider this as the fourth equation. Alright, so if you can see here, since we have only s and t, two unknowns, that means it will involve only two equations that you need to simplify. Alright, so meaning here we will use equation number 3, and let's say we want to use equation number 1. Okay, so next step is we want to use the substitution method. So we will substitute equation number 4 into equation number 1, for example. You can also use the equation number 2 if you want to. Okay, so it is up to you. Alright, okay, now let's continue. Substitute 4 into 1, then you will get it is 2 times 7 minus 5s minus 3 equals to 2s minus 1. Alright, then we will have 14 minus 10s minus 3 equals to 2s minus 1, and simplify, you will have here 12s equals to 14 minus 3 is 11 plus 1, you will get it is 12, and lastly you will get your s equals to 1. Okay, so this is your s. So when your s equals to 1, now you will get your t will be equals to 7 minus 5 times 1, which means your t is 2. Alright, next, to find the point, okay, to find the point, we will substitute the value of s or the value of t in your equation of lines. Okay, so let's say we use the value of s, then we will substitute in equation L2. Alright, so from L2, okay, you will have your x will be equals to, so 2s minus 1, 2 times 1 minus 1 equals to 1. Okay, then y will be equals to negative 3s plus 1. Negative 3 times 1 plus 1, so you will get it is negative 2, and your z will be equals to 5s minus 4. That means you will have 5 times 1 minus 4, which is equals to 1. Alright, so now what will be your intersection point? So the intersection point will be 1, negative 2, and 1. Don't forget, please check using L1. Alright, so from L1 you will have to substitute the value of t. Alright, now you will have your x will be 2 times 2, 2t minus 3, 2 times 2 minus 3, so you will get 1. Your y will be 4t, so it is coming from here. Okay, 4t, so your t is 2 minus 10. Alright, so you will get negative 2, and another one, your z is negative t, so negative 2 plus 3, which is equals to 1, and you will get the same point, which is 1, negative 2, and 1. Okay, so this is the answer for the intersection point between line 1 and line 2. Okay, thank you.